Hello everyone. In this video, I would like to show how can we connect the PLC to Matlab Simulink by using OPC UA. Recently, I did a couple tests connecting the Siemens PLC or backup PLC using OPC UA communication, tested the communication between the software and the hardware. Recently, I also did a couple tests using the Matlab and the system identification tool to model the process. Also, I did a couple simple tests on the Simulink by myself. And then it come up one question for myself. Is there some way we can connect the PLC, for example, the Siemens controller, to Matlab? That would be a common question because usually from the research team the Matlab is a very strong and professional tools for them to do the research. But from the industry so PLC is a very common tool, and that is a very professional tool. You can use the PLC, collect the data, implement the algorithm, and to do the verification and the validation. So one is a engineering tool, one is a research tool. How can we connect this software with the Siemens hardware controller? As we know, the OPC UA has became the common used protocol building up the communication between the hardware and hardware between the software, especially the different brands hardware between the different software. So in this video, our topic is connect the Siemens controller hardware and Matlab Simulink, connect them together using the OPC UA. One important example that comes from the Siemens support website, that is this ID here, 1097491187. So that is a virtual commissioning with a SIMATIC and a Simulink. That is a very good example. However, when I implement this use case 2, that is the exact topic we are going to show. That is using the PLC Sim advanced software to simulate one Siemens hardware and use the OPC UA communicate with Matlab Simulink, exchange the data. So the PID controller is in the PLC side, and the simulated process model that is in the Simulink side. However, when I build up the OPC communication between the Matlab and the Siemens controller, I found an error. So I will show this error. Eventually, I found alternative way to solve this. I think this is a value to show what the problem inside this case and how I solve that. So as we can see from this picture, the PID controller locates in the PLC side, and Matlab and Simulink running as a process model. The communication between the PLC hardware and Matlab Simulink, they are communicating through the OPC UA protocol. To implement this function, or to learn how we can implement this function, we can download the manual, especially this use case 2. So this explained how we can use the OPC UA to build up the communication between the Matlab and the PLC controller. In this case, that controller is a Siemens S7 1500 controller, and we will use SIMATIC PLC Sim advanced software to simulate that hardware. And also there's one project that based on the version 14. And also we have a Simulink project example. So basically we will use the menu and the TI Portal project and the Simulink sample project. And in this video, the TI Portal software, I will use the version 16 version. And the PLC Sim Advanced, I will use the version 3.0 update 1. Both of them, they are latest version till now. The Matlab, what I'm using, that is a version R2018B. Once you download that TI Portal project, so that file name is this. So we extract this project, and I will cut this, otherwise this directory is too long. I will cut it out, delete this. Okay, that is a TI Portal project. And by default, from the example, that TI Portal project, that is a version 14. I will use the version 16, the latest version, to open this. Open TI Portal version 16. because originally this sample project was version 14, so currently we are using version 16. It pop up this window, ask us to upgrade all those blocks. Yes. So this project is upgraded. So we will rename this project. So this is a PLC underscore PLC Sim Advanced. I will rename, give a different name on this project. I will rename this project named PLC Matlab OPC UA. In my laptop, the TI Portal system, currently the system what I'm using, that is in a virtual machine. And Matlab is installed in my host machine. And let's find out the controller. In this example, controller configured in this project, that is 1511. So I will change to the latest firmware, change device. Okay, so existing one, that's the version 2.0, is a little bit old. So I'm gonna change to a new one. I'm going to change to a version 2.6. Okay, click OK. Okay, I changed to this controller to 1511 version 2.6. So to implement the OPC UA server function, in this controller, there's one important setting in this controller, OPC UA here. And in this case, the PLC will run as an OPC UA server, and the Matlab will run as an OPC UA client. So under this PLC properties, we will activate the OPC UA server here. Currently, the controller IP address is this. So I will change this IP address to demonstrate for your case. Maybe you will use another IP address. Okay, I will set this controller as 192.168.1.100. Go back to the OPC UA server side. So once we change the IP address, we will see this is your OPC UA server address. The port we will use 4840. And other settings, we can leave all those settings as a default. Okay, keep in mind that this server certificate, we will use this default certificate. And this is the security setting. In this case, we will use no security. So in this sample project, there are two data need to communicate between the PLC and the Matlab. One is a fan force, one is a current angle. Current angle, that is the feedback signal from the process model from Matlab Simulink. And the fan force, that is a PID control signal from the PID control algorithm from the PLC side to the Matlab Simulink. To allow those two data communicated between the PLC and the Matlab, we need to check out the read and write accessible checkbox here. We need to check all of them. Also, we need to check out from the DB properties. We need to check out this attributes. So we need to check data block accessible from OPC UA. Allows this DB published to the OPC UA. So quickly go through the example program. So in this project, there are two PID controllers. So it's already programmed. One is a instant DB, that's the PID compact for OPC communication. One is for another example. So we will use this. So where is this PID control program? Under this cyclic OB, organization block. Okay, there are two instant DB here. So the function block from this instant DB, that is a PID compact, that is a PID controller for the 1500 controller. The cycle time of this organization block, that is 20 milliseconds. So this OB30 call the PID control every 20 milliseconds as a cycle time. And from this two PID controller, we will use the first one. So the input, that is a process value feedback. So this comes from the OPC UA interface, and this received from the Matlab Simulink. And the PID control signal will output to the OPC interface to here, the fan force. The Matlab Simulink will simulate one process and give a process value transfer to this current angle process value interface. And the PID control signal will transfer to this dB and transfer to the Matlab Simulink. Matlab Simulink will use this signal as a control signal. And in this project, we also have a HMI here. Okay. And HMI has a screen. We can double click this trend configuration. So as we know, the angle set point is a green color, and the input, that process value feedback, will be a yellow color, and PID control signal, that is orange color. Okay, so because this is a simple program already built up, so we won't take a too long time on this project. So we save the project and compile again, ready to download. To run this program, I will use a PLC Sim Advanced here. That is a version 3.0. Okay, I will select this PLC Sim virtual Ethernet adapter. Okay, and in my laptop, we need to check out the IP address. So from my Ethernet interface, so this PLC Sim Advanced interface, what I'm using, that is a 192.168.1.99. Okay. And from here, I will build up one controller. Okay, that name is PLC underscore Matlab underscore OPC UA. Okay, that IP address, as we said in the PLC project, that is a 1.100, and the subnet mask 255.255.0. Okay, click this start. So after we click the start, this software will build up one instant PLC. As we can see, this controller build up. So this PLC Sim Advanced software running as a simulated PLC controller, so that for this test, we do not need one actual hardware. Okay. So currently, the PLC with this name and with this IP address is prepared. So we are going to download. To download this project to this simulated PLC, we can hit this download to device. Okay, so make sure currently we are download our PLC controller 1.100. This is a config IP address, and PGPC interface. We will select this Siemens PLC Sim Virtual Ethernet Adapter, which is the same like here, and select this interface. Okay, hit the start, search this Reddit controller. Okay, so the TI portal already found this simulated controller. Let's hit the load. Let's watch this status. Okay, hit the load. Okay, so here we can click this no action or click this start module directly, hit the finish, it will start. So if you hit that no action, you can manually hit this start CPU to start the controller. Okay, make sure the controller is running. Okay, currently we download the controller PLC side. The PLC is running, and then we will start the HMI. So this HMI project, that is a touch panel, 12-inch comfort panel, touch panel project. To allow our laptop to run this HMI, we can operate something on this HMI. We can use this HMI simulation. But to allow this HMI to communicate with this simulated PLC, we need to do one more setting. So we need to go from here, we need to search control panel. Okay, and find out this set PGPC interface. And make sure this i7 online step 7 point to this interface, PLC SIM virtual Ethernet adapter. Firstly, you need to make sure that is i7 online step 7 here, and browse this virtual Ethernet adapter. Ethernet adapter TCP IP. And make sure this interface i7 online point to this Siemens PLC SIM virtual Ethernet adapter. Click OK. And once we build up this, so once we start this HMI, the HMI will communicate with this, because when we start the simulation, that i7 online interface will serve for the communication interface, and that interface will point to this simulated controller here. And this is a PID trend, and this is a PID assign point, and this is a feedback, and this is a auto or manual mode. Currently 3 means in auto mode. Okay, now if we set 20, we will see this is a PID control, but feedback is 0 because currently we haven't built up the connection between the PLC to Matlab. Okay, so now the HMI is running and the simulated PLC is running. So we basically finish the PLC side. We will shift to the Matlab side. And the Matlab is installed in my host machine. Firstly, my host machine, let's check out the IP address in my host machine. So my host machine, the IP address is 1.199. And the simulated PLC, the IP address is 1.100. From this host machine, firstly, let's use this UA Expert from Unified Automation, this OPC client software, to test the OPC connection between this client to the server. The server is a PLC. And from here, let's click this Add Server. Using this tool, because here it can pop up the information. So in case the communication has something wrong, we can use those diagnose info to test the communication. Okay, from this custom discovery, let's double click and type in the OPC server IP address 192.168.1.100. That is that PLC IP address, and the port number 4840. Okay, click the OK. We can see this OPC client already found this OPC UA server. And let's use this non-security and click the OK. Okay, so we can see this client already browsed the tags here from that controller. And from this data blocks global, we can see this OPC interface, that is that DB name. And in that DB, we have two data, current angle, that feedback signal, and the fan force, that is a PID control signal. Let's drag these two tags here. And currently, because we set 20, so it has a 20 value here, but feedback is 0 because this feedback signal comes from the Matlab Simulink. We haven't built up that communication yet. Okay, this is the node ID. The PLC side, the OPC UA server is running properly, so we will shift to the Matlab side. From the Siemens support website, we will download this Matlab Simulink example project. Once you extract that, we will use a Simulink use case tool, that is the communication between the PLC and the Matlab Simulink by using OPC UA. Okay, so this is a Simulink file, and this is a .m that file, the functions. So let's open the Matlab. To check out the detail of how we can use the Matlab side, you can download the manual from the website using the same number here, that is a case 2. And basically we would have two steps. One step, that is test this .m, there's functions, and then use the Matlab Simulink. This is that .m, the function. And then this is the Matlab Simulink file. So from here, we will exchange one block. That is the OPC UA interface. Okay. So in that interface, the interface will call that .m file. That's the read OPC function. Okay. So with this example, our operation will be very simple. However, from this code, it has something wrong. I will explain and show how we can solve that. Okay. Firstly, from this directory, you need to go to the directory your files locates, and then double-click this .m. So this file is used to set up the OPC UA connection between the Matlab and the OPC UA server from outside. And firstly, we need to find this. This is a UA client, OPC UA. The IP address we need to change because currently the IP address from the PLC side, that is a 1.100, and the port, that is a 4840. Okay. From here, we will see using this code, we read the fan force and also read the current angle. Exchange the data between the server and the client. Okay, so ideally, once we change this IP address according to your actual PLC IP address, so once we hit this run, we will see the info on here to show if the communication already set up correctly. Okay, and let's quickly go to the Simulink side. Double click this. Okay, this is a Simulink side. So the key idea of this Simulink in this menu, it's explained, especially from this main menu. It explained how this Simulink works as a simulated process. Okay, this area, that is a simulated process. And here, that is the PID controller. The PID control signal go to this simulated process and then receive the process feedback to that PID controller. And this area, that is the PLC PID algorithm. So we need the OPC UA communicate between this Simulink and the PLC. So this feedback will transfer to the PLC, and the PLC control signal will transfer to the Matlab Simulink, and then give to this simulated process. Okay, if we double click here, that is a read underscore OPC underscore function. So what is this? This actually comes from our Matlab. So that is this name, read underscore OPC underscore function here. You can see this. This name must be the same. Okay. We will leave those as a default. That means this function is playing a very important role. So let's look at what the input and what the output of this function. Okay. So if we go through this function, so the input, that is a y input, that is the input of this function. So eventually the output, that is x. So that means this whole function will read the data into this y. Y will be used in this function, and eventually the output will go to the x. So if we trace down this x, the x will wrote by this test value, and test value is here, and this value is controlled by this read value UA client, this variable node ID in. That variable node ID in, that comes from the fun false. So as we can see, so this X signal actually is come from OPC UA server, that PID in the PLC side, that PID control signal. And this variable node out, that comes from the current angle. So this current angle will read into this variable node out. The variable node out actually comes from this y, the input of this function. If we go back to this Simulink, so that is the y input, and this is the x. So x is a PID control signal, and the feedback from this simulated process, that is the y for this function. Okay, here. So it seems everything is okay. So let's hit this run. Let's firstly run this read OPC underscore function. Check out the communication. So once we hit this, it will pop up this error, shows this cannot communicate. Honestly, I took a couple days to figure out this, and eventually I found out it seems the problem comes from this command, find node by name. So this name has something wrong to browse the tags from the OPC UA server. So the reason why I found this, let's check out this way. Let's manually type in the command, check out what's going on in here. So firstly, let's type in this UA client. We use the exact same command and hit the enter, and we will see. So currently it's disconnected, and then let's type in this control UA client. Let's manually run line by line. It wait for a couple seconds, and let's hit this UA client, check out the current status, and we will see it's connected, which is good. So the last problem, that is OPC UA tags browse. And then let's type in this server nodes equal browse name space. Namespace. And here we need to use this UA client. Let's type in this command. So it will pop up this. This is the OPC UA client browse. Browse for the namespace. So from this list, ideally it should be the same as OPC UA's client from this Unified Automation UA Expert, right? So ideally, this browse should browse this. So let's go to find out that. So PLC Matlab OPC UA, if you recall, we renamed that project to PLC Matlab OPC UA, which is correct, no problem here. They all found that. And let's go to the next layer. So next layer, that is the data blocks global. Data block global. Browse. Here, it shows an icon only. But in this client here, we should see this OPC interface. That is the data block, the name. And this is the text name. But from this Matlab here, this side, it doesn't show up this. So that means using this namespace method, we cannot browse the text here. So that is why in this .im file, it's using this find node by name. It cannot find that. So that means this find node by name is not working properly. We have to use a name ID. So how can we do that? So from this code, so we need to change this 2 lines here. Use another command. We will browse the node name rather than the tag name. So what is a node name? So if we go to the Unified Automation UA Expert, so every time when we browse one UA server tag here, you will find out some attribute or properties here. So this identifier, so this node ID here, that is the actual address from OPC UA side for each tag. So for example, for this current angle, the actual address, that is a namespace 3, and the string, and that is a string type, and this full name, that is a OPC interface dot current angle. We need to use this name. And then let's go to the Matlab side. We can close this. And from the Matlab side, this time we will firstly comment this couple lines. So this time, this variable node in will be replaced by a new command, that is the OPC UA node. So how to use this command? We can hit the F1. So we can search the OPC UA node, hit the F1, search this help. So let's look at the syntax from this command. So to use this node, we can follow this way. So this is that name ID number. In our case, that is a 3. And this is that tag name. And the tag name here, actually, we should use this. This is the full tag name. Let's double click here. So it's very valuable. We use this Unified Automation client to search or to have a rough idea what the actual OPC UA tag name for this tag. So let's copy here. This is that full name. And this is that namespace index number 3. Okay, so we will use this. And let's go to the Matlab side. And in our case, we will leave this here. We will type number 3. That is the namespace. Here, firstly, let's type in the single quote and paste the full name of that OPC UA tag full name. And here, I will add this UA client. That means this read from this UA client, this connection. Okay, Same way for this UA out. Oh, sorry, this variable. This is for variable out because it's a current angle read to the variable node out. Okay. And for this variable in, here we will use the similar way OPC UA node. Okay, so let's go to the find false from the client, and this let's hit this. This is a find false. So the full name, that is the OPC interface dot find false. Double click, and I will copy this full name. And namespace index, that is number 3. Same way, single comma, and paste this full name here. And that connection read from this connection. So we will use the OPC UA node. This command replace the existing one. And this command will read the find false, this tag OPC UA address, to this variable node in here. Same idea as this node out. If here, so using the read value based on this connection, so the tag find false will read to this variable here. So from this write value, we will write y into this current angle here. Okay. After we change this time, let's hit this run and check out the status. No enough input. Okay, so that makes sense because this .m, this function has an input here because we just single run this function. So this function should call from the Simulink. So let's test the Simulink side. Likely all the code is working just because it's an input. We haven't have any value go into this function. So let's hit the save and shift to the Simulink side. Double click. Okay. So again, this block is calling this function. So this time, let's hit the run. Okay, it's running now. And let's double click this scope. Okay, so currently it has a data here. That means the communication is working. The blue line, that is the process value. And this orange line, that is a control signal from the PID controller. Okay. Likely this PID parameter is not working properly. Maybe we need to fine tuning. But fine tuning is not our main topic in this video. Our main topic, that is discuss how we can build up the OPC UA connection between the Matlab Simulink and the PLC. And now this process is working on 20. Okay, let's type in the 30 set point. Let's see. So it got a new set point. So this process value is going up. And this is a control signal. So likely this K is too big. We can shrink the K a little bit. Okay, so let's shift to the PLC side. And I will put a window here. So this window, that is a Matlab. And this is our simulated PLC. And this is a HMI screen. Okay, if I type in, let's say 40. So we will see this trend. They are similar. We will see this is a control signal. This is a feedback. We will see this feedback, they are the same. This is from the Simulink scope, and this is a HMI train. And this data is showing here. Now the control, that is 12, and feedback is 40. if we go to the PLC side, and if we online browse the data from this OPC interface, these two tags, let's hit the online monitoring. Okay, so we will see this is the false control signal 12, that is a feedback 40. So now the value is 40 and the control signal that is 12.6 is here. And if we set up the new value from the HMI, so this is HMI, let's set up 20. Okay. So this is a process change. And this is the Simulink, okay, the same train, right? And if we shrink down and look at this, compare this two value, we will see the process value, that is the 20 here. Control signal is here. Likely the K is too big. Let's shrink the K a little bit. If we go to the configuration, okay, this is the PID parameter here. So now the proportional gain, that is a 2. Let's shrink to 1.2. Do a test. Okay, I changed to 1.2 and let's see this time. And that is 20. Let's change to 30. Okay, this time looks better than before. All right. So using this way, the PID controller is inside the PLC, and we can use the Matlab Simulink to run as a simulated process. So using this way, we can connect engineering and research together, and we can use a different Matlab model to run as a simulated process model, and use the engineering PLC PID controller to control this process. So honestly, without the OPC UA before, it's a little bit hard. Basically, we have to use the software controller. From Siemens side, if we go back to 10 years ago, they called WinAC, and now they called i7-5000S. And from the back-off side, we have to use the TE1400. That package connect the Matlab and the back-off controller together. That is not quite easy, and because there are so many tiny settings and environment settings inside that area. As we can see, using this OPC UA, that pave a way to connect the controller, Allen Bradley, Siemens, or Backoff, or Omron, connect them to the Matlab Simulink. And if you want to read the more detail, highly recommend you read this main document and user case 2, this document at first, and use this sample program, simulator sample, and TI portal sample as an example to digest what the detailed code inside. It's very helpful. Alright, that's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.